Hi everyone. Today we wrap up the Principles module with the 9th and last lecture discussing map projections. So this is a bit of cartography, moving on from the simple geography of latitude and longitude. But you're going to look at a lot of data in this course and in any sort of Earth system science course, oceanography in particular. And it's important to remind oneself at the outset that whatever map you're looking at is a two-dimensional representation of the surface of the Earth, which is not actually two-dimensional, right? The Earth is a sphere. So you have to project this spherical surface of the Earth onto some sort of two-dimensional plane, and there's no perfect way to do that. And there's a couple of essential elements to think about when you're choosing a projection or when you're looking at a projection that's been chosen for presentation. And that's the area, the angle, the orientation, and the ease of matching. And so we're going to define each of these. So different projections of a map serve different purposes. Area is one. So if you want to keep, a projection, let's say the goal of your projection is to keep the areas correct. And that's important if you're trying to compare different parts of the Earth's surface with each other. And I'll show you, for example, the Mercator projection. Doesn't do a very good job with that. Another thing to worry about is the angle. So keeping the angle consistent is incredibly important if you want to use a map for navigation, which is based on compass bearings, right? Or something in relation to the magnetic North Pole. And then orientation. This one's pretty important. It's not always, but you rarely see maps where the orientation has been completely skewed. And what that means is essentially that, as you go up the map, you're going north. As you go to the left of the map, you're going west. And then ease of matching. If you have a map of the Atlantic Ocean in one projection and a map of the Indian Ocean in another projection, you can't put those two together without redrawing the entire map. And so that sometimes is also not super useful. It's easier, of course, to think about this problem when you're looking at things. So this is called the Mercator projection. And this is one way to put the spherical globe on a map. So useful things about the Mercator projection are that you've got nice latitude and longitude lines that are a grid. So in terms of forming 90 degrees, so that's useful. But what this projection does is it takes those converging longitudinal lines and it really spreads them out. So it super distorts the high latitudes. And I'm just giving you the example here. So Greenland, which is this continent, is essentially on this map roughly the same size of Africa. So there's no fidelity of area in this map, right? They've completely gotten rid of the idea of fidelity of area in order to present it with more fidelity of angle. So in reality, Greenland's quite small. It fits within Africa 14 times. It fits within South America 9 times. And there's no way you can tell that by looking at this map, right? I mean, it's just not even close to giving you that sense of the world. So useful for navigation is this map, right? Like if you sail from Cape Town along this line, you will indeed hit that part of Antarctica. But if you then go on to sail, let's say you use the lines, you sail due west and then you sail due north and you run into Greenland, you might be really shocked by how small it is in reality. All right, so that's not a great projection in that sense. These projections are equal area projections. All right, so you can see just by looking, some of these are a little bit odd, but let's say this one. So now there's Greenland. Now it's the right size as compared to Africa and South America, because we've preserved area here, but there's no fidelity of angle. So you couldn't use these maps to navigate. You would end up getting a little bit lost because, you wouldn't be able to accurately move around the globe, especially, looking at something like this version of the projection. So it's tough to have a map that keeps everything. Here, this is one that you're going to see a lot in oceanography. It's frequently used for data presentation. And this is nice because so your latitudes are horizontal and they're equal latitudinal bands. But it's allowed for some convergence of longitude. So again, you can see area here is doing pretty well because Greenland looks sort of as small as it should. And this is a nice view also because it preserves area. It's a nice way to present oceanographic data. So there's some Twitter links that I've put on the lessons pages. This, again, the type of problem this issue of projection, really requires you looking and sort of understanding things spatially. But I thought it was worth just taking a moment to point out, that all the data or whatever you guys are going to be looking at, you should think about how it's being projected, what information is maybe being lost because of the way it's being projected, or what information is being skewed or, looks a bit funky as a result.